So let's not waste time and let's start. Good morning, everyone. I'm really glad that I can be here and talk about our architecture journey. I hope you are doing fine. I mean, you just had your breakfast, right? So I think you're full and you are full of energy. You are happy. So let's proceed. It works. First, what will be in my presentation? We will start with some general talk. What is an architecture? Why do we need one? And what factors should we consider when designing one? Also, we will look at tools that we can use when documenting an architecture. Then I will move into specific talk about our iOS architecture at ČSOB. Its history, how we started, how it evolved, what challenges we had along the way, and what is the current state of our architecture. So, first things first, what is an architecture, right? I could use many definitions here, but I like to keep it simple. It's some kind of blueprint, some kind of foundation, your base building blocks upon which you build your application. Definitely when you go to Google, right, and you type mobile development, you will get so many articles about architecture and MVC, Viper, MVVM, and so on. It's basically just your code structure, how you structure your code, your project, how each component integrates with each other, and how they communicate. Then, why? Is it necessary for iOS development? I know some of you might be, well, in the end, most of the apps are glorified JSON parsers. We don't need architecture, right? Because what matters is what user sees, right? I don't think that's correct. I mean, for some apps, right, with like one screen, two screens, it's okay to like have everything in one file, and yeah, you only live once. But there are complex applications, right? And if you don't have a solid foundation, solid architecture, then creating new features becomes slower, and you can hit some walls that will not help you during the development process. So you need architecture because you want your app to be able to scale, to be testable, to maintain the app, and to have some kind of performance. I mean, if your UI starts freezing, that's actually pretty bad, right? That's bad user experience. And also, you work in team, so you want to be able to work parallelly, right? I lost the button. Found it. Now, how do you design an architecture, right? First things first, requirement analysis is extremely important. I mean, ask questions, communicate with your stakeholders, with your customer, because you don't want to miss a thing. You have to fully understand the context of the application. Funny thing is, don't leave out implicit requirements. That's actually something that's very funny, because for some customers, implicit requirements are something different. I mean, for some users, they will say, I mean, of course the app should be available offline and should do that and that. That's obvious, isn't it? No, it's not. And it takes time to develop these features, and it also affects our architecture. So don't be afraid. Ask. Now, you need to consider if the scale of the app, right? If you are creating prototype or something that will be used just once, like for this event, then yeah, you don't have to think much of the architecture. Then also, what are the other requirements like performance? Do we need to test it? Every developer will say, yeah, testing is good, but in the end, you don't do it, usually. Now, you have to consider other technologies that you will use. And something I think is overlooked is human factor, the expertise in your team. Because usually you have some senior developers and some less experienced developers. And if you over-engineer your architecture for no reason, without any real benefit, then you just complicate things for others. So you have to find the right balance. Also, discuss pros and cons of each architecture when choosing or designing one. Do we need to be reactive, and so on. And also important for management and business, cost and resource constraints. Like if your deadline is in 2 hours, then yeah, you know the deal. It's spaghetti code time. Anyway, what tools can we use? I want to say that it's extremely important to document your architecture, because during onboarding, new developers can understand how they should work with you. Don't be scared of UML diagrams, enterprise architect, and so on. I know we are developers. We don't like those tools. That's for analysts. But it's good to somehow describe your architecture. Even text is enough. It's actually something we use at ČSOB. We described our architecture in a Markdown file without any diagrams and so on. So in the end, I think the ultimate tool is pen and paper, so you can capture your thoughts and your thought process and the app. So I mentioned you don't need diagrams because there are some rules, and I had a great teacher during my studies at my university, professor for architecture design, and he said something that still sticks to me to this day, and it's this. It basically says you don't have to understand the diagrams, and I know it's kind of hot take if you are an analyst, and so cover your ears, don't listen to me, but the important thing is that it has to convey your message. When you give someone your description of your architecture, they have to understand. It can be just a text, it can be simple shapes, it doesn't matter if you use a rectangle here, circle here, doesn't matter. Ignore the standards, just send your message. And I think that's actually pretty beautiful. So, what is the best iOS architecture for our apps? Well, in my own opinion, of course, subjective, the answer is simple. One that satisfies the requirements. I don't think there is any cookie cutter architecture for our apps. But I have some recommendations that you should consider when designing architecture. As I mentioned, the scale of your app. Of course, if it's a school project, you know the deal. Don't do architecture, just like do it in one file, it works, right? Then consider all requirements and communicate with your team, with everyone in your team and other stakeholders. And something I tend to do, and some of my colleagues too, do not over-engineer because it's cool. I know there is new kit on the block, TCA, right? It's cool to use it, but if you don't need its benefits, then why do bother? Why would you over-engineer something that just complicates things? Having 10 layers of mappers and so on, just not to use them, is like not very effective. Also, do not be overly strict. That's something that might be considered also a hot take. And that's because I think it's okay to sometimes bend your architectural rules, even though it has some constraints, because there might be some simpler parts of your applications that don't have to be in full clean architecture, right? And I think it's correct to use some other patterns and some little hacks so you can finish your job faster. Of course, don't do spaghetti code, but just be flexible. What I also important, document your architecture, as I mentioned, and do not be afraid to change and refactor your parts, because if you start building upon spaghetti code, yeah, it will go bad. I mean, I've seen some things. I've seen a whole database in one string. That was something. So please, if you see that, refactor it. Don't be afraid. Now, the fun part, our architecture. How do we do it at ČSOB, right? So, first, what is ČSOB Smart? In simple terms, we can say it's banking application, right? The common use case. You load the app, you check your balance, everything seems good, hopefully, and then you pay your bills, if you can. But we are called Smart because we offer way more than just this use case. We offer something that we could call beyond banking. We have news. You can get yourself insured, you can invest and manage your products, cards, and so much more. Currently, I think we have about hundreds of thousands active users daily. and about 1.5 million total users of ČSOB Smart. So, let's talk about our starter phase, how we began. That's the boring part, because you know the deal. You create new project, and well, it's just new project. It's empty. There's no architecture, and you do the initial boring setup. For someone, it's actually pretty fun to do scripts and to work in Bash. So, okay, I understand that. But we did not have any architecture. We prepared some basic UI components, and we started first architectural talks and decisions how we will proceed based on requirements for the application. There were some key factors that we had to consider during those talks, and that was, well, we will have a big team, right? And they have to work in parallel, because we don't want to, well, slow down the development process of other teams. There are multiple teams working on this application. Also, it has to scale. We are starting with simple features, like 10 features. Right now, we have about 48 features. So it scaled a lot. And also our team expanded a lot. We wanted to be able to test each component. And also we wanted to have some kind of adaptability, to be future-proof in case some new technology emerges and changes the way we think. Not spoiler alert, definitely not Swift UI changes. Then something more interesting happened, and that was in the phase of our architecture. There is already something fun, something technical, right? Not the general talk. We went with coordinator pattern that we modified a little. You know the deal. It's something that manages your presentations, because we wanted to decouple the navigation from view controllers to something else. We call it flows, but in the end, in its true essence, it's coordinator pattern. Also, first modularization, so we can work in parallel. Each feature and its use cases are grouped into feature, like cards feature, payments feature, and so on. And we had 3 main building blocks: presentation that contained the flows of the features, domain that had tons of stuff. I will be talking about it, and data that did the heavy lifting, the jobs, the services, the API calls, and the fun stuff. Let me talk a little about flows. As I mentioned, it's a modified coordinator pattern, and our roll up was based upon one object, that is base flow. And it was simple. It had children flows and manages its life cycle. You know, adds them, removes them, gets existing flows and modifies it if needed. Each flow has its router. Router was some kind of object that had reference to other UI kit object, like navigation controller, tab bar controller, or UI window, and used its APIs to present the screens. So for example, window flow had window router, navigation flow or nav flow had navigation router, and used navigation controller in the background to show next screens. But that might seem boring, so let's look at the code. This is the base flow. You can see there are children flows, and there are the methods I mentioned to add flow and remove flow, and some other things that are needed for the flow. We used SwInject for dependency injection. Now, more specifically, this is specific flow that uses navigation flow. Navigation flow also inherits from the base flow you just seen. And every flow has start method. It can start with or without deep link. And it has to do these things. Prepare the view controller. Of course, load the necessary dependencies from assembler and prepare other stuff, and then return the view controller. Then use your router to show that view controller, and then handle deep link if it exists. Also, view controller can call back to the flow to display other screen or to completely start a new flow. Like you can see here, we have something that it can call handle link because it has to show something we call action flow. It's basically web view in the end. Also, let me go back. No, remember the unfinished closure that we have. So you can see we have to manually manage our life cycle of the flows, and I will be talking about it. So just like take a mental picture. Now I will be talking about it. Flows. Unfortunately, UI. It did more than UI and navigation. Some flows had some logic in it, and that kind of broke the coordinator pattern. Some logic should have been on the screens before it dismisses and so on. But unfortunately, we had some loading, some API calls in the flows, and in the end, retrospectively, that was tech debt. Of course, we changed that, we refactored that, but it happened. And possible memory leaks, because if someone forgot to implement on finish the method and remove the flow, then you will have your flow in the memory. And at some time, I think we had like 20 leaked flows. So yeah, we also fixed that, don't worry. We are not wasting your battery life anymore. Now, the big things. In the picture, you can see some of the use cases. I think it's like 10% of them, because this app is massive. It has tons of use cases. And for data management, we went with repository pattern. You probably know the deal. But we enhanced it with use cases. Retrospectively, it was not a great idea, but we wanted to do that to have some kind of traceability with Enterprise Architect. Domain contained usually protocols, declarations of the objects, and something we could call services, but services should have been repositories. But yeah, that was a mistake. That was tech debt. But I want to mention it here. And then data had repository implementations and did the heavy lifting. But again, code is better. So, as you can see, we always had some kind of use case. Here, it's use case to get cards for the application. And you can see use case does only one thing, calls repository. And for every use case, there is always some mocked use case, so we can use it for a preview or for testing. And then in data, we have the repository implementation, where there will be call to our services, to our backend authorizations, and the heavy lifting. I left out the code, you know the deal, NDA. So now, of course, as I mentioned, we had some mocked use cases and test use cases and so on, and we used Swinject for dependency injection, so we can easily switch between a real implementation and test implementation. And also our app offers demo mode, so you can use the app without having an account, and you can get a feel of it. So we have actually something like mock, demo, test, and real implementations. It kind of takes time to create just one use case. So there were some flaws. As I mentioned, retrospectively, use cases were unnecessary. You've seen it, right? Only thing it did, it called the repository. Why won't the view models or presenters just use the repository in the end? And yeah, it should have been like that. That was a mistake. Also, we did not well define what is use case. Should use case have some logic? Should it just call repository? And in the end, there are still some use cases that do some logic, and then something does everything in the repository implementations. But also, mapping is done in use cases, so it's kind of scattered all over the place. Of course, we fixed these most of these problems, but I want to mention that we should have gone with just the repository pattern. Now, the fun thing, the presentation, the screen is the actual UI that the users see and can interact with. First things first, we did not use storyboards. Again, I've seen some things like with 100 storyboards linked between each other, and it's mess. It's quality spaghetti. So we went with UI in code. And for the screens, we used MVP, Model View Presenter. Let me talk about our MVP. So there is diagram. Don't worry, it's not definitely perfect, but it will convey the message. So we have view, and that user uses to interact with the application, and it sends events to presenter. A presenter has two states: view state and document state. The reason why we have two is because view state is an enumeration. It's well-defined state for the view, loading state, loaded state, error state. And document state contains the data, and not every data is needed for the view state, so that's why we have two. So user clicks on the button, some service or the use cases you've seen are called, and then based on the result, we can navigate to other screens or modify document state and then say, view state, we have new data, update yourself to some state. Again, code is better. So this is presenter. Every presenter inherits from base presenter. My mistake, I forgot to show you what base presenter is. It's missing, but it has only one job. It creates closure that calls render in the view when view state changes. That's all it does. So in the left picture, you can see the presenter. It has document state. It does some stuff, and it also modifies view state when needed. View state are well-defined states of the view, like loading, loaded, and then you can see the user interactions. He changed something in the text field. Again, we could call some APIs. Does not happen here because it's very simple presenter. We modify document state, and then we modify the view state. There is flaw. View state is well not defined. Again, just like the use cases. First things first, view renders everything. Imagine just like one thing changes, and you say view state to loaded, and view will do all the things for the loaded state. That's not optimal, right? So we started creating some pseudo states like partially loaded, halfly loaded, form filled, not form filled, and suddenly you had like 10 states, and it was like, well, if it's loaded, but also form filled, is it loaded or just form filled? It did not make sense, and we tried to reduce it because our main idea, our first idea, was flawed. There is just not loading, loaded, and error states, right? There are more states or some partial states, and we did not consider that. But in the end, it was a minor flaw, and it worked. But, so, we were satisfied. Overall, we were satisfied. I mean, not everyone. Some of us would say, nah, it was terrible, man. But I think it was decent. It was very decent, like 80% satisfied. In the end, it was easy to understand, it was scalable, it was testable. I mean, it fulfilled everything we wanted. And we used it for a long time, right? And then something happened. And you know what happened, right? Now, some of you will be like, no, SwiftUI was from iOS 13. Yes, it was. But we had discussions, and we think, and we thought, and still think that iOS 13 SwiftUI was not suitable. The API was very limited. So we waited for iOS 14 to start using SwiftUI. So when we bumped up the minimal versions of our app to iOS 14, lots had to change. So let's something we call transition phase. how do we deal with Swift UI? What architectures should we use? I mean, our MVP does not work for Swift UI, right? Vue itself is Vue model in Apple terms, and we were baffled. We had to do other architecture talks, and we decided during this transition, before we decide on the architecture, let's use Swift UI for some parts or extremely easy screens. Biggest problems that we found out when we started using Swift UI, and the preview canvas, it's amazing, right? But our domain was massive. Like, it had everything in it. The domain declared everything, and building the domain took ages. I mean, when loading Swift UI preview that linked the domain, I could go shopping, return, and still it would be loading. I mean, we had Intel, not M1, and so on. So it took ages. It took 20 minutes for a clean build. So yeah, that was problematic. And also, we could not use MVP for our architecture. So we did some big decisions based on existing flaws I mentioned. First, flaws were manually handled their life cycle, so we should rethink how we handle flows. Simplify domain, make it more granular, break it into little pieces that we can test, and we can link only if needed. And for the Swift UI, we went with MVVM. I know there might be some architecture experts that will be, well, it's not MVVM in its true form, but let's go, it's very similar to MVVM. So, new beginning that changed our whole architecture that we still use. It was critical redesign. Type of development. So when we started fixing bugs or creating new feature, we always refactored related use cases from the domain to kits, and then we refactored the code from UI kit to Swift UI. I will be talking about it in more detail. So, domain. Our main idea to this day, because domain still exists, it's small already, but still exists, is to get rid of the domain and use new approach. Kits with clients and services. Clients are heavily inspired, or basically just a copy from Point3 boys, amazing team, and their library Point3 dependencies. So, what is a kit? Well, it groups similar use cases. In domain, we would have tons of card use cases, and we refactored that to cards kit. Also, we migrated each project or each feature and kit to Swift Package Manager. So, feature can use kits when needed, and kits can be linked between each other. So, usually you will have some very basic kit, utility kit, that does some formatting, number conversion, and so on. And that is used by other kits. Clients. That's something we use instead of repositories. Basically, it replaces them completely. And it moves from protocol-based dependency to struct-based dependency. Again, it is inspired by Point3 dependencies. It helps us simply create more testable and mockable use cases or clients, and it's less verbose to do so because you just have to modify the closures. You don't have to implement the whole protocol and so on. And every client is backed by services. Services is where heavy lifting happens, API calls, and so on. Again, code is better. So this is client from our location kit, if I'm not mistaken, maybe maps kit, I'm not sure at that moment, but it handles locations, uses locations for the maps. And you can see there's always a demo implementation. It just creates the struct with some default data, and then in data there is live implementation, and you can see it is backed by the location service, where there will be the logic, the API calls to get the user locations, to authorize the location permissions, and so on. I also mentioned on the previous slide, or there was, that they are backed by services. We wanted to have stateless services only because, well, they are easier to manage. But in the end, we don't have backend for that. It would have to be redesigned as a whole. So we have to cache some data, and that's what stateful service is. So you can see examples of stateless service that just like call APIs and do stuffs, and stateful services that can save data. Also, as I mentioned, these kits are linked by feature. Feature, again, groups similar screens. For example, cards feature has card block, changing of card limits, changing card address, ratioing a new card. Again, it was in a Swift Package Manager, and also we redesigned our flows into something we call flow and feature wrapper. Each feature has its own feature wrapper. So this is how feature basically looks. It has some screens, it has view models because we are using MVVM, and it has view objects when you don't want to use the whole entity, but just something for the UI. The whole optional block is because some kits, some clients can exist only for the feature. I mean, location client or payments client is used on so many places, right? But then you have very specific clients that should not be available. So our main idea is, if other screens or other features have to use your logic, then move it to some kit. If it's only for that feature, leave it in that kit. That's why the whole client structure is also in the feature. We call that feature-based client. Then global-based clients are in kits. Now, redesigned flows. Each feature has flow. Flow handles navigation in the feature, and feature wrapper handles the flow and navigation outside the feature. So starting product detail feature from card feature, for example, totally different features, but they have to be linked somehow. Again, code is better. So every flow has start method with default implementation, and that fixed our issue with manually handling the on-finish closure. Now you don't have to do on-finish, remove flow, and so on. It is maintained by UIKit lifecycle by the flow container, because when the view dismisses, it is automatically released from the memory, and so is the flow. So, for example, it can look like this. Every flow has to create the view controller, and every flow handles its flow, its feature flow in it. So you can see we send some route to show some other screen, or to dismiss something, or to navigate somewhere outside. This is the feature wrapper. Basically, it has to do two jobs: create the flow and handle the navigation outside the features. Usage is pretty simple. Instead of creating the whole flow and so on, in the old flows we still have to use, because it's difficult to migrate everything at once, right? We use feature wrapper that we just call feature wrapper make, and then we push it onto the stack, and then the navigation itself is already handled in the flow and in the feature wrapper. Now the also fun thing, how our screen is handled. So we are using MVVM. We kinda redesigned it something like this. So view again sends user interactions, and the actions are handled. It can be navigating to other screens, and it uses the dependencies clients from the kits, and updates the state, and the state is automatically well mapped to the UI in Swift UI, so you can see the changes immediately. It's basically MVVM, right? So it's better to show it in code. So I did not use our specific view model because it would be long and it wouldn't fit. So I created example how it looks like. So there is input if needed. I could have left that out. And there is state. And there are dependencies that are always clients, nothing else. At least we try to. And every time you create view model, you have to inject the dependencies. And then you have methods that use those dependencies and update the state. You can see that text fields are linked to the state. It has minor flaw that every time you update something in the state, the whole view starts rendering, right? I know SwiftUI is optimized, but still it's not great. But we did not want to have like multiple published properties, so we went with one. It has some minor performance impact, but it doesn't matter for our application. I mean, if you had some kind of very responsive applications like drawing something and so on, then yeah, that will be a problem. But for us, it's not problematic at all. This is ours, and this is something we still use to this day. I'm very proud that we went with this. It just works and it's scalable. But what is the future for us? Well, we want to keep refactoring legacy flows. The app is massive. And when we changed or transitioned to SwiftUI, we changed tons of flows, but there are so many use cases, so many flows we still have to change, and we are working hard to do that. Also, as I mentioned, getting rid of the domain. Right now we have like 60 kits. It works, it's very granular, it's testable, but there are still some use cases that we want to move to kits if needed. Also because, you know, observable object is not that performant, so we want to use something better. Maybe observable from iOS 17, but you know, iOS 17 will be like for us in like 2 and more years, so it's not usable. But maybe we are considering using something from Point3 that basically created their own observable macro. And then consider using Point3 dependency library for our clients, and eventually remove Swinject because Point3 dependencies will be enough. And one main thing is we want to never stop improving our code, rethinking our architecture. Maybe in 10 years there will be SwiftUI 0.10 and it will be something totally different and we will have to change our architecture again. But we have great developers that are able to do that. So our main motto is never stop improving. And this is our current state. And if you have any questions, go ahead, I'll be glad to answer them.
Thank you so much. So as you can see, we have several questions, but let's answer just one so as not to be too long into the break. So please, mentioned kits are Swift packages. How many kits are there? And how do you manage features for main repo? How do you automate the versioning?
Yeah, okay, so right now I think it's about 50 kits plus minus 10. How do we manage features for a main repo? I'm not sure, but what is the person asking? I can answer in detail if you come to me later. We basically have features in the project, in the workspace. We don't publish them anywhere because we don't have to use them in other apps. We have only one app, so it is maintained in one project. And I don't think we automate the versioning because it's locally based packages that we use only in one app. So there's that. No. We keep it in one repo. Yeah.
Okay.
Actually, but it's a great question because we wanted to create repos for some of the kits, like the design system kit, right? Because it can be used by other banking applications similar to it and that use one design system. So yeah, but it was not needed and still is not needed, so we did not do that.
Yeah, perfect. Thank you very much. As you can see, there are many more questions. I will ask Jan to, when you leave the room, just stay outside for a bit and please go to Jan and ask him those questions. We don't have time to answer all of those right now. But one more thing about Slido. We will always start a poll or a rating of the talk at the end of the talk and during the break. So if you would like to rate Jan's talk, you can go to Slido to the tab which is called Polls and give him as many stars as you want. We will be really happy. The feedback is important not just for the speaker, also for us as organizers. So thanks again. I will see you in 8 minutes actually with the talk of Petr Dvořák. So see you soon. Jan, thank you again and please go and answer the questions.